Bismillahirrahmanirrahim. Friends, I'm me Muhammad Wasif on your channel Meets Electro World. Fellows, today we are going to explore a subatomic particle careening in space and like electron, right? Just imagine an electron is careening in space and building concentric circular magnetic field around it. Today we are going to see how to calculate strength of that field from that moving subatomic particle like electron or proton. So let's start on. What we need is the Biot-Savart law to calculate the strength of magnetic field at a distance from the moving subatomic particle like an electron or a proton. Like this is just imagine, this is an electron, right? And it is moving in space. Now it is building concentric circular magnetic field around it while it's motion. When it's not moving, right, when it's stationary, there is no magnetic field. When it is moving, it builds a magnetic field around it, right? So we are going to find the strength of this magnetic field at any point. Like, let's suppose if I'm saying this is our point on which we want to calculate this charge Q. This charge Q is moving here, right? And this is the point on which we want to calculate the strength. So for that purpose, we are using this Biot-Savart law put forward by two scientists, right? And it's very useful to calculate the magnetic field at a distance from the moving subatomic particle. Now, let's start on with a scenario here. Imagine an electron with a charge 1.6 multiplied by 10 raised to the power minus 19 coulomb is moving in space with a velocity v equals 2 multiplied by 10 raised to the power 5 meter per second. Now this is the angle between charge and the field is 90 degree. This is you can say like we have some data here, and what required is the strength of the magnetic field at a distance. We call it R because it's used as R in the formula equals to whatever it is, right? So now here, this is the Biot-Savart law. This is the magnetic field is equal to mu naught divided by 4 pi. This mu naught is a constant, right? It's you can say like permeability of the free space, and the value is 4 pi multiplied by 10 raised to the power minus 7. So it's a constant. 4 pi is a constant, and here we have the q. This is the charge. This is the velocity, right? And we simplify this thing. And before I proceed towards the simplification of this one, we'll see this Biot-Savart law. What this law is saying, this law is basically saying that this magnetic field that we are going to manipulate is directly proportional to the charge, to the velocity, and it depends on the angle as well, because there are some explanation of this thing if we are using a unit vector, right? So anyway, I'll tell you both of how to simplify the formula using the unit vector and the normal one, right, with the cross product. The first one, we proceed with the cross product, right? Here is the formula, and I'm trying to simplify it, right? So it's mu naught divided by 4 pi into this q into v. It's a vector, right? Now this r, one r will cancel, and the cross product will bring the sine theta. Sine theta. This r squared. One r is cancelled with this r, so we have a form like this. So this is one way, and the other is if you are using a unit vector, right? Then what happens is we'll do some little math here. Mu naught over 4 pi qv divided by r cube into r unit vector, right? Now the magnetic field is equals to this thing. Now have a look what we get after solving this one. right? This is the magnitude now. Now the magnitude of the B means the magnetic field is equals to mu naught over 4 pi Q into V into this. This is R squared, right? When we are doing this one with unit vector. Now this unit vector is replaced with 1, right? And 1 into. Now the unit vector is telling us about two things about the it's unit vector first thing, and the second is the direction. So for the direction we are introducing the sine theta here, right? So this is solved, and this r square will come here, and what we get is mu naught over 4 pi q v, this sine theta, because theta here in our case is the charge and the field is making the angle of 90 degree. So because the charge is here somewhere here, right? If we draw a tangent towards this point, this is the point on which we want the strength, right? This point P. P is the point. So we draw a tangent here, right? So it makes an angle here. This angle, we are talking about this angle. Now, right now we are saying that this angle is 90 degrees. So it means this point is at 90 degree to the moving subatomic particle. Now to find the direction, we need the right hand rule, right? So because the charge is moving in this direction and the magnetic field is like this. So it means from here it is going inside of the board, and from this point it is coming out of the board, right? Right hand rule. So in this way you can calculate, no, this way it is going inside, and this way it is coming out of the board using right hand rule. It is coming out and it is going inside. So this is the dot and this is the cross. It is coming out and this is coming in. So it means on this point field is inside this board, right? Towards the inside of the board, right? So that's how to find the direction. Now for the magnitude we need this formula, and this becomes r squared. The sine 90 is 1, so 1 into 1, so it's r squared. So this is the final form we are going to deploy in our this scenario. So let's move towards the scenario, and we will calculate the strength of the magnetic field at a distance. This is 2 multiplied by 10 raised to the power minus 9 meters from the moving subatomic particle, right? Let's do the little calculation here. Let's start on. Now, this is the magnitude we are calculating is equals to mu naught over 4 pi, I'm solving it, into qv divided by r squared sine theta. Now substituting the values here, mu naught is 4 pi multiplied by 10 to the power minus 7, so just substitute it. Divided by 4 pi into q. Now in our scenario here, right, the charge is, the moving electron is, the charge is 1.6 multiplied by 10 to the power minus 19 coulombs. So I'm putting the value here. I'm just substituting the value. It's 1.6 multiplied by 10 raised to the power minus 19 into the velocity. This is the velocity on which the electron is moving. So I'm substituting the velocity is 2 multiplied by 10 raised to the power 5, right? Divided by r. Now r is this 2 multiplied by 10 raised to the power minus 9 meters away from the moving subatomic particle. So I'm putting it divided by the 2 multiplied by 10 raised to the power minus 9 whole square. That's all. We put the values. Now regarding the theta, because theta is 90, right? This is making 90. So sine 90 is the highest one, it's 1. So substituting it, it's 1. Right? So just simplify it a little more. What we get is the magnitude of the field is equals to this 4 pi will cancel, right? And what we get is 1 multiplied by 10 raised to the power minus 7, right? This is 1 over 10 to the power minus 7 into the magnitude of this electron, right, into its speed. This divided by, this is 4 multiplied by 10 raised to the power minus 18, right? So simplify it a little bit more. What we get is 1 multiplied by 1.6 multiplied by 2 divided by 4 multiplied by 10 raised to the power minus 7 minus 19 plus 5. This is minus, so moving it from denominator to here, so it will become plus 18. 1, 2, 3, 4. 1, 2, 3, 4, right? So that's all it is. So simplify it a little bit more. What we get is it's 0.8, right? Yes, it's 0.8 multiplied by 10 raised to the power 18, and that's 23. It's minus 26 plus 23, and the final magnitude we get is 0.8 multiplied by 10 raised to the power minus 3 Teslas. So that's we were looking for. This is the magnitude on this point P in space. This is the charge, moving charge, and this is the point where we want this magnetic field, the magnitude of the magnetic field, and this is the magnitude. It's 0.8 multiplied by 10 raised to the power minus 3 Teslas. So fellows, hope so. It's all clear to you what happens when a subatomic particle is in motion, and how to calculate the magnetic field around it, thanks to the Biot-Savart law. Thank you, fellows. And if you like this video, click on the thumbs up button, share my videos with your friends, and subscribe my channel. Share my channel with your families and friends. Thanks for watching.